All right, this is problem 3 from the SOA's released problems for exam P. And you can do it algebraically or graphically. The solution given by the SOA is done algebraically, and I think graphically is really a lot easier to think through. So we're given that the probability of A union B equals 0.7, and the probability of A union not B equals 0.9. Find the probability of A. So let's work that out graphically, starting with this one right here. The probability of A union B is equal to 0.7. So we sketch out our Venn diagrams and our box that represents the universe of the problem. And we'll let this be A, this be B, and we're being told that everything inside of A and B, the intersection A alone, B alone, all of that is equal to 0.7, which implies that everything outside of A and B is equal to 0.3. And now let's take the second statement that we have. Probability of A union not B equals 0.9, and let's create a picture of that. It's A and B. And now let's shade. So we have A, but not B. So we're going to skip the intersection. And then union with everything that's not B. So if you take a second to look at the graph here, what we've actually been given here with this statement, probability of A union not B, is the same as the probability of not B equals 0.9. Because I mean, look at the picture, right? We've shaded in everything that's not B. And if we know that, then we know the complementary value. The probability of B is 0.1. So if you're like me, you might get excited at this point and think, I'm going to be able to solve this problem. I know this little formula right here. P of A plus P of B minus the intersection of A and B is going to be equal to the probability of A union B. And we can start plugging stuff in, right? We know P of B is 0.1. We know P of A union B is 0.7. And so we can write a new statement. And we can do a little algebra on that. Subtract the 0.1 from both sides. We get P of A minus the intersection is equal to 0.6. So at this point, you're at least down to a 50-50. The answer choice, either only D or E, makes sense. But, that might be good enough for an exam. If you can't go any further, hey, at least you got the 50-50. But of course, we can do better than that. So what I'm going to do is recreate these two graphs, but as one. And we're going to have a close look at what it is we actually know. Because we don't have to go too deep into more algebra in order to get to a final answer here. So we know that everything outside the circles is 0.3. And we know that B and B alone is 0.1. So all that leaves is this intersection right here and this right here, the probability of A alone. So we can take that graph and just write another statement right here. We know that if we take the probability of A and A alone, and we add on the probability of the intersection of A and B, we're going to get, 1 minus 0.1 and minus 0.3. So that is also going to be equal to 0.6. And at this point in time, the answer really is staring us right in the face. Sometimes it just takes a while to really understand what it is we're actually doing when we solve these problems. That's why the diagrams are so helpful. So it's important to think about what you write down. So I have the probability of A minus the intersection equals 0.6. The probability of A plus the intersection equals 0.6. If I have a thing and I take something away, or I add that same thing that I'm taking away and I get the same value, this thing has got to be 0. These are mutually exclusive events. And you can kind of prove it to yourself. We can add these two equations together. 2 times the probability of A, well, that's a 0 pair. So we're going to get 1.2 divide by 2. And the probability of A is 0.6. So the correct answer is D. And these are mutually exclusive events. And I think this sort of graphical way is a more helpful way to think about it than what you're going to see in the answer key.